So from the previous footage, we saw how the ball hits the robber, and we will look into the forces and the distance and the velocity that is required in order for the ball to hit the robber right on time. Now this is the projectile motion that the ball will go through, and this will be the distance covered. This was the distance between the person throwing the ball and the person getting hit. Now, to find that, let's say the initial distance between the person and the robber is 3 meters, and that is exactly when the person throws the ball towards the robber. Considering that the ball is in the air for 3 seconds, and the robber is running at a rate of 4 meters per second, this is the distance that is covered. So the distance between them at the point of impact is 15 meters. So what are the forces and what is the acceleration that is required for this to take place? So we will split the velocity into 2 components, the x and y component. So the one on the x-axis is vx and the one on the y-axis is vy. So these are the calculations that we have to follow in order to get the vx and vy, and using Pythagoras we will find that the magnitude of the velocity is 15.605 meters per second, and the angle between the horizontal axis and the velocity of the ball is 71.312 degrees.
And next, we have figured out some methods to improve our shooting power. So let's proceed. The first one is we can actually improve our physical strength, and we can usually we can go to gym or do more exercises so that our muscle will build muscle and be stronger. And when your muscle is stronger, the force produced by your arm will be increasing. And when the force is increasing, the velocity of the ball will be increased, and hence the power will also increase. The second method is we can make adjustment to the shooting style. So before we are throwing a ball, we can actually run, and the action of running will produce a forward momentum, which will increase your velocity while you are throwing a ball. And once the velocity is increased, the impulsive force will also be increased.
Another example of the adjustment to the shooting style is the pitching movement of the, as you can see here, the pitching movement of the baseball player. So this pitching movement, if you do it very fast, it actually can kill a person. So the speed is very, very fast. And we can do a final jerk to the ball so that it can produce a spinning ball which moves faster. And the next is the type and material of the ball. So this aspect must be taken into consideration because in our case we use a standard volleyball, so its size is quite big actually, and we recommend to use a smaller ball such as a golf ball. So one of the factor is because volleyball has a softer surface area and golf ball has a harder surface area. So when you throw a thing with a hard surface area, it will decrease your time of impact. So according to the impulsive force formula, which is F equals to change of momentum over time, so time is inversely proportional to the impulsive force. So if we decrease the time of impact, so the impulsive force will be higher, and the impact, like the person who got struck by the ball will feel more painful. And another factor is that smaller size will cause more pressure on the impact surface when the ball hits the person. And next, the lighter ball, which makes us easier to throw, it will produce a large velocity and thus a large impulsive force. And the other thing is the angle of the ball. So this is the original angle that we calculated in our case, which is 73 point something degree, and after several calculations, we found that 45 degrees of the angle of throwing of the ball will produce a maximum range of motion, which means the ball will move in the greatest distance from the thrower. And that if the angle is negative, which is smaller than 0, because it is lower than the axis, so it will produce a negative angle. Some of this movement is, for example, like a spike of the volleyball or a smash of the badminton. So if we use this angle, we can actually hit a target more precisely.
Now, the acceleration and force will be calculated using these equations of motion. Over here, we can find acceleration because we already know the velocity. We are assuming that the ball is still in the hand when it's accelerating, and it is following a linear acceleration, and the distance it covers while it's still in the hand is 0.5 meters. Additionally, the force at which the ball is thrown therefore becomes 73.05 newtons. So this will be the free body diagram, where the force P is the force from the hand and the weight is the weight due to its mass, which is 2.943 newtons. And the kinetic diagram will be MA, which is 0.3 times acceleration, and as we found from the previous slides, that acceleration is 243.5 meters per second square. Thank you.
Now we are going to find the thing which is the velocity just before it hits the rubber. So to find the thing, find the in x component and y component. For x component, there's no acceleration. So dx equals to initial velocity of x, which means it equals to 5 meters per second. Okay, in the same direction. For the dy, since there's acceleration, so we use dy equals to initial dy plus at. So in this one, we can substitute our value, which is the initial 14.72 plus the gravitational acceleration, which is negative 5.81, and time, which is 3, and that's how we can get our dy, which is 14.648 meters per second. And to get the magnitude, we need to use this equation, which is this formula, which is square root dx squared plus vy squared, and we substitute our value, which is 5 and negative 14.648, and we can get 15.477. And for the angle, for the final velocity, we can use this formula, which is factor negative 14.648 over 5, which is the y component over the x. And that's how we can get the angle, which is negative 71.53. So, to find the impulsive force, we need to do some assumption, which is we assume that the impact time for the collision between the ball and the rubber is 0.2 seconds, and the velocity of the rubber falling down is 5 meters per second. And according to the conservation of momentum, the total momentum before the collision is equal to the total momentum after the collision. And that's how we can get this. We substitute our value before the collision, after the collision, and we can get the velocity after the collision, which is negative 60.3569. And now, that's how we can find our impulsive force in this situation. So when the ball hits the rubber, the impulsive force will decide whether the rubber will fall down. So that we use this equation, which is m v minus u over impact time, and we substitute our value 0.3 negative 60.3569 minus 15.477 over 2, and we get our impulsive force, which is negative 113.75 Newton.
Singing, we will rock you.
So, taking over from my friend who was just briefly explained just now, I'm here to talk about the change in energy. So, there's two energy that we're talking about, which is the potential and the kinetic energy. So, the kinetic energy is defined as the work needed to accelerate a body of a given mass from rest to its stated velocity, while for potential energy, for example, an object, for example, possesses gravitational potential energy if it's positioned at a height above or below the zero height. So technically speaking, there will be kinetic energy over here, but there will be no potential energy. And here there will be potential and kinetic energy, and that is what we're going to focus more on today, which is how to calculate the potential energy and the kinetic energy at the peak. So taking an assumption from my friend before, which is the initial velocity is 15.605 meters per second, and the angle found over here is 71.312 degrees. So the adjacent formula, you're using the adjacent formula. Here you'll get the velocity at the peak, which is over here, which is 5 meters per second. And here the formula over here is the conservation of energy. So meaning that the total energy at the launching of the ball is equal to the total energy at the peak. So take in consideration that the kinetic energy is 1 over 2 mv squared, and just sub in the assumption made for the ball, which is 0.3 kg, the weight of the ball. So just sub in everything, you'll get the kinetic energy for both sides. And for potential energy, since there's no potential energy at the beginning, so they'll be equal to 0, and to find the potential energy at the peak, you'll just subtract this, and you'll get the potential energy at the peak, which is 32.77 joules. And that's all for me today.
Okay, so next we will proceed to the calculation of power efficiency. So have you ever wondered when you are throwing a ball towards a person, so how much power is produced by your hand and how much power output is consumed by your hand? So the power produced by hand on the ball, the formula is equals to force times velocity. So the power output is equals to the force of the ball, force of the hand act on the ball, which is 73.05 Newton, and the velocity of the ball is 15.605 meter per second. And hence, through the calculation, we can obtain a value of 1139 something, which is the power output, and then we assume that our muscle have an efficiency of 0.3, and the formula for the efficiency is power output over power input, and hence we can obtain the value of a power input through the calculation, which is 3799.8175 kg meter per second. And this power input indicates that it is the power produced by the cell through your metabolism activities.